everyone. Myself Bushra Anjum and my teammates are Ayisha, Zainab and Gauramma. So today we are here for a COA assignment which is based on factorial of small number using 8051 assembly language. So the introduction is assembly language programming is a low-level method of writing programs that directly communicate with the computer's hardware. It provides precise control over CPU and memory operation, allowing developers to manipulate registers, flag, and addresses directly. In microcontroller-based systems such as the 8051, assembly language plays a vital role in managing hardware components efficiently. Compared to high-level languages, assembly offers faster execution and better optimization for small embedded applications. Assembly programming is especially useful in scenarios where systems resources are limited or where performance is critical. By using low-level instructions, programmers can write compact, high-speed code that performs arithmetic, logical, and control operation efficiently. So the next is and the objectives are design and implementation to design assembly programs that perform fundamental CPU operations such as arithmetic, logical, comparison, and looping. Efficiency analysis to analyze how efficiently instructions are used, aiming to reduce the program length and how memory usage. Third is problem solving skill enhancement to develop low level program solving and debugging skill using registers, memory addressing, and control instruction. Next is a practical understanding of loops to demonstrate how iterative operations like factorial calculations are implemented using looping constraints, that is ZNZ or DCR. So the next part will be continued by Aisha. Thank you.
Hello everyone, myself Ayisha S. On coming to the problem statement, factorial of small number less than or equal to 05H, 5H, memory location, input number stored at 85H, result stored at 86H, task description, read the number n from memory location 85H, calculation like n factorial is equal to n into n minus 1 into n minus 1 into 1. Store the result at location 86H. For numbers less than or equal to 5H, the factorial fits in 1 byte. For example, if n is equal to 4H, then factorial is equal to 4 into 3 into 2 into 1, that is 24. That is stored in hexadecimal 18H. Hence, 18H will be stored at memory location. On coming to the implementation part, the algorithm the algorithm for calculating the factorial of small number less than or equal to 5H in 8051 assembly language involves a series of systematic steps that guide how the microcontroller processes and computes the result. This logic demonstrates how looping and arithmetic operations can be performed directly through register manipulation and instruction level control. Let's go through each step in depth. Step 1, start the program. The execution begins at start address usually defined by the assembler directive org 000H. This marks the beginning of the program where the instructions will be stored in the microcontroller's memory. At this point, all registers and memory locations are ready to be used for data manipulation. The program initializes the required registers and prepare to fetch the input number. Step 2, load the memory address 85H where the number is stored. In this step, the program accesses the memory location 85H which contains the input number whose factorial is to be calculated. For instance, if the value stored at address 85H is 4H, it means we need to calculate 4 factorial. The instruction used for this operation is generally move A85H. This means the content from memory location 85H is loaded into the accumulator register for immediate use. Step 3, move the number from memory to another register. To perform repeated multiplication, we need another register to act as a counter or decrementing variable. Hence, the number fetched from memory is copied into register B. Step 4, initialize the accumulator with 1H. Before multiplication starts, we must initialize one register, usually the accumulator, which the value 1H because factorial multiplication starts from 1. This initialize act as a base case since any number multiplied by 1 gives the number itself. Step 5, check if the number is 0. Before starting the loop, the program checks whether the input number is 00H. If the input is 0, then by definition 0 factorial is equal to 1. Hence, in this case, the program directly stores 1H in the output memory location 86H and stops execution. This condition avoids unnecessary looping and ensures correctness for the edge case input. Step 6, multiply accumulator with the current number. Now begin the core operation repeated multiplication. The accumulator, which holds the running products, is multiplied by the value in register B, which starts from the original number. This means multiply the content of A and B and store the result in register A, low byte, and B, high byte. Since we are dealing with small numbers less than or equal to 5H, the result easily fits within 8 bits. Step 7, decrement the number, that is DCRB. Once a multiplication cycle is complete, the program must reduce the number by 1 to continue the factorial process with the next smaller integer. Step 8, continue multiplying until b becomes 0. This step forms the looping structure of the program. The jump if not 0 instruction is used to check whether b has reached 0 or not. If b is not equal to 0, the program jumps back to the multiplication steps and continue multiplying. If b is equal to 0, the loop terminates as all necessary multiplication have been completed. Step 9, store the final result in memory location 86H. After the loop ends, the accumulator holds the final factorial result. The value is then moved back to a predefined memory location 86H for output or verification. The instruction used like move 86H, A. This makes the result accessible in memory for further use or display. Step 10, stop the program. Finally, the program ends with the instruction end. Next, code and output will be continued by Zainab.
So, hello everyone. I am here to explain the code and the output. So this image is showing a 8051 assembly program running in Keel Vision. The program calculates the factorial of the number stored in the memory. So this factorial program for the 8051 microcontroller explanation is the mul AB, that means which multiplies the A into B, stores the result value in A and B, but since the factorials are small, here B is equal to 1. The DJ NZ R1 back decrements R1 each loop and jumps back until R1 is equal to 0. This creates a loop multiplying numbers from n down to 1. The program demonstrates the looping and the multiplication in 8051 assembly. It uses the register indirect addressing R0 and R2 to access memory. The DJNZ is a key instruction to create a decrementing loop. The mul AB is used for multiplication between A and B registers. The final result is stored in the memory and can be viewed in the Keel memory window. The program works correctly for small numbers factorials that fit in the 8 bits. So here you can see that the address that we have given in the memory is 0 into 85. When we enter the any numbers we give in this 00 memory address, the values get stored in the registers and the value is shown as the blue and the white thing here.
So this is all about the program and the output. The next will be continued by Gauri.
Factorial program successfully computes the factorial of a small numbers 5 Hz stored at memory location 85 Hz and save the result at 86 Hz by using the JNZ jump if not zero and DCR decrement register instructions. The program efficiently creates a loop to perform repetitive multiplications. The accumulations plays a key role in performing the multiplications and storing intermediate results. The sequence diagram illustrates clear data flow between memory and registers, demonstrating proper use to control flow and arithmetic operations in assembly language. Overall, the experiment demonstrates how looping, accumulate operations, and memory handling can be combined to perform interactive calculations like factorial computation in 8085 microprocessor programming. Thank you.